Welcome to the class, my dear students. So, in today's lecture, I'm going to explain you about the testing of the hypothesis when a small sample is being taken. How to identify that whether it is small sample or a large sample? In a small sample, the sample size will be less than 30. So that is what the observation. And in the previous lecture, I have clearly mentioned when to use test static Z alpha when greater than 30, and when do you accept the null hypothesis or reject the hypothesis. All these we have done in the previous lectures. Now let us consider this one as the testing of the hypothesis of the small sample. So first of all, assumptions of t-test. See, these are the questions which are very much important for the examination point of view. Of course, for the competitive exams when you go in future, then that will be very much useful for you to understand. And of course, in present scenario, you will be having so many multiple choice questions also. You can do it properly. Now, let us go to the assumptions for t-test. What do you mean by the assumption for t-test here? It's normal. Okay. The population from which the sample is drawn is normal. From the normal population only it will be drawn, from the normal distribution. And the sample observations are of course independent, and that sample is of course random. And the population standard deviation is unknown here. In the previous lectures, in the previous concept, it is we are doing the testing of the hypothesis of the large sample when the sigma is unknown at that time. Now the population standard deviation is unknown. Okay. Now while doing the t-test, you should understand what is meant by the degrees of freedom. That means the number of classes to which the value can be assigned arbitrarily is known as the degrees of freedom. That means if the sample population size you are how many samples you can take is the possibility, the number of classes to which the value can be assigned arbitrarily is n minus 1 number of samples we can take when n is the sample size. So it will be distributed with n minus 1 degrees of freedom, we can say. So now the properties of distribution, this is another important thing. The variable t lies between minus infinity to infinity. That is what the thing. First of all, that the variable t lies between minus infinity to infinity. And the standard normal deviation distribution, it is also symmetrical and has mean is equal to 0. Correct? So that is what, like the standard normal distribution, even the t distribution is also symmetrical and has the mean 0. And sigma square of t distributions is greater than 1, but it becomes 1 as degrees of freedom increases, and thus the sample size becomes large. Okay, so the variance of t distribution approaches the variance of the normal distribution as the sample size increases, and the t distribution is lower at the mean and higher at the tails than the normal distribution is lower at the mean. That means, suppose if you take the normal distribution, so it is lower in the mean, at the mean, and higher at the tails. So t distribution has proportionally greater area at its nails than the normal distribution. So that means in t distribution you will be having greater area at the tails, like this, at the tails. But normal distribution is like this. Okay, is a normal distribution. So now let us have a look about these problems. What is the random sample of 16 values are drawn from the normal distribution is found to have a mean of 41.5. So sample of 16 values means it is clear and is less than 30. So small sample. First I notice what is small sample or not, or large sample. And then is a mean of population mean is 41.5. Sigma is equal to 2.75. On the basis, is there any reason to reject the hypothesis of the population mean mu is equal to 43? So these are the things given in the problem. So given that population mean is equal to 43, and what is the sample mean is given by 41.5, and what is the we wanted to find out n is equal to 16, it is less than 30. Correct? Therefore, it is small sample. That is the small sample. And then you have the standard deviation. The standard deviation is found for what? Have a mean of this one and standard deviation is this. So you know what is S here. That is the given by S is given by 2.795. And to reason to reject the hypothesis that the population mean is mu is equal to 43. So here he has not mentioned it is less than or greater than or something. So what is alpha here now? Alpha on the basis here we will not be given alpha because we are going to see in the T table, correct? It is in the small it is in the for the small sample. So we have to check the T table. In the T table we have to calculate the value. Most probably generally in the exam they may give, but if they have not given in the T table which will be provided, in that we have to find out. Okay, so these are the things given, right? So mu the what is the null hypothesis now? The null hypothesis is H naught. What is H naught? Is given by mu is equal to 43. And what is the alternate hypothesis? The alternate hypothesis is given by H1 is equal to mu, and it is not given anything like less than 43 or greater than 43, correct? So mu not equal to 43. So it is clear that it is a two-tailed. It is two-tailed. Now what is the calculated value? T calculated value. Now we have to find out what is the calculated value of T. That is given by the formula. It is x bar minus mu over S by square root of n minus 1, because it is the small sample. So now all these values we know already. So what is x bar is 41.5 and mu is 43 over standard deviation is 2.795 divided by n is 16. So it is root over 16 minus 1 is 15. So this is what the value, calculated value. So when you calculate this, use the calculator. 2.078 with the negative sign. When you take the positive, when you take the absolute value, then mod value 2.078 is your calculated value. Now I'll give you what is the T small sample. That means for the small sample, what is the T table? When we have done the confidence interval, we have done for the small sample what is the T table. So this is the T table, if you understand. And now what is our n here? 16. So 16 minus 1 is the 15. 15 is the degrees of freedom. So we have to check 15 degrees is freedom. And what is the value here? It is for the value for T calculated value is given by at 15, it is 0.05 level of significance. It is 2.131. So 2.13. So this is what we have to write down. So let us now go to do these problems now with this value as 2.13 as your tabulated value. So what is given here? Alpha is given to you. It is 2.9 on the basis that generally if it is not given, alpha value is not given, suppose you can take it as alpha as 0.05, 95% confidence if it is not given. If it is given, okay, otherwise take it as 0.05 level of confidence. So what is the degrees of freedom here? It is n minus 1. N minus 1 means 16 minus 1 is 50. So what is T table value? T table value is what? T degrees of freedom is n minus 1 comma alpha. What is T? N minus 1 comma alpha means 15 comma 0.05 level of significance. And that value we have got it here as it is given by 2.13. We have done it. So now next is, it is also again, it is a two-tail. Okay, so now t calculated value is this value 2.13, sorry, t calculated value is 2.078 and t table value is this one. Therefore what you can say, t calculated value is less than t table value. Therefore accept the null hypothesis. Accept H naught. I accept the null hypothesis. So, is there any reason to reject the hypothesis that mu is equal to? No, there is no reason to reject. So, we have to accept the null hypothesis. I hope you could understand how to solve this type of problems on the small sample. Okay, on the small sample because n is 16. I hope you could understand very clearly about this. Yes, thank you.